Hello, 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 hello. Okay. Let's move on.
That we have to use code to create and instance a scene dynamically. Code. And if you did this for hundreds of objects, it would be incredibly difficult to manage. The next major aspect I want to work on is to create custom scenes in code. And this is another really important aspect. Let's talk about why. So far, we always created scenes inside of the editor. For example, we made the gate, we made the player, we made lots of things like that. But sometimes this isn't possible or desirable in the game. For example, when we are working with the lasers, something we are going to do for this part, we cannot just create a scene and then add it because we have to do all of that dynamically. Meaning we want to create a laser whenever the player is shooting. And for that, we have to use code to create and instance a scene. Let's talk about how this is going to work. Number one, we have to create a scene in the first place. This we are still going to do manually, which means we are going to put together a couple of nodes that are going to constitute the laser, and that's going to be one scene. This part we have already done multiple times. It shouldn't be too difficult at this point. Number two, this is something we haven't done yet. We have to create an instance of the scene. The way you have to think about it is that when we are creating a scene, we are basically creating a blueprint, which by itself doesn't do anything. And once we are creating an instance, this is a really important word, then we are creating an actual node that we could use in another scene. And once we have this instance, we need to go through one more step. And that is we have to add this new instance of the node to the node tree. This is important because at step number 2, when we have an instance, we only basically have a node that we can work with, but it's not attached to our current scene. And for that, we need step number 3, where we add it to the node tree. Only then can we actually see and use it inside of the game. So with that, we have quite a bit of material to go through. Let's jump into Godot and let's have a look. Back in the editor, I want to first of all close the gate because we don't need this part anymore. Next up, I want to create a new scene. And now I have to figure out how to create a basic scene for the laser. And the most important part for now is we have to think about what the root node is going to be. And let's talk about how we have to approach this. We have area 2D, static body 2D, rigid body 2D, and character body 2D. Now, when we are creating the laser, we want to move the laser, obviously, so we have to choose one of these that can collide with something and that can move. The one I'm going to go with is the area 2D. This is a node we can move perfectly fine, and it can also detect collisions, which is basically all we need. Alternatively, you could also use a rigid body 2D or even a character body 2D. Although you probably wouldn't want to. A character body 2D would probably be overkill because a laser ultimately is quite simple. And a rigid body 2D also isn't really that necessary because a laser is moving at a constant speed. We don't really need any kind of advanced physics in there. Although later on, when we are working with the grenade, we are going to work with a rigid body 2D. For now though, we don't need it. The way you want to think about it is that you always want to use the simplest node that you can possibly use. In this case, this would be area 2D. I want to create another node, which is going to be an area 2D. This area 2D, I want to rename to laser right away. And now we have to do the usual. We want to add a sprite, and I want to add a collision shape 2D. For the sprite, we will need a texture, which we get inside of graphics, and in there we have projectiles. The file we need for this one is called blue. I just have to drag it in there, and then we are getting the image of a laser. Next up, we have to add the collision shape. For that, I am going to go with something we haven't used yet, which is a capsule. This I want to extend a bit, and basically what this one is a rectangle with rounded corners. Once again, as well, I want to keep the center of this collision shape around the origin point, so position 0 and 0. So I'm going to move the image to align with the collision shape. I think that's looking mostly okay. You can play around with this a lot, and if you want to have a really well-working game, these small details are really what make a good game. So I think this one is a pretty good start. This seems reasonably okay. Which means I can save the entire scene under scenes, and in there I want to create a new folder. Let's call it projectiles. And I can save it in there. And now we have a laser. This would cover the first part. So now we have created a scene. Next up, we have to create an instance of this scene in the new scene where we want to work with this. What that means is I want to use this laser inside of the level. Specifically, I want to create an instance of the laser when we are triggering the on-player laser event. For that, we have to go through two steps. First of all, we have to preload the scene we have just created. And this happens all the way at the top. I want to create a new variable. Let's call it var laser scene. And to preload a scene, we need the function preload. And this preload wants to have a scene. Since we do have quite a lot of stuff in there, you usually would just want to type the name of the scene, and then Godot is quite intelligent about it and gives you the scene. Make sure that the ending is TSCN. This is a scene. If you have PNG or anything other than TSCN in there, something probably went wrong. You can be even more aggressive about it and force a certain data type. The data type we're looking for here is called a packed scene. So now we have a scene ready that we can use. What we have to work on next is we have to create an instance of the scene. This is turning the actual scene into a node that we can use in our current scene. That is actually quite easily done, and I want to do all of that inside of onPlayer laser. All I want to do in here is create a new variable that I'm going to call laser. And this laser is going to be an instance, which means I want to get the laser scene, the one we created up here, and then run the method instantiate on it. With that, we have an instance of the scene, which is covering part 2 of our requirement. All that is left to do is to add this scene to the node tree. This we can do with a simple function. It is called addChild. And the child we want to add in this case is going to be the laser. With that, we should be good to go. Let me run the game and let's just see what happens. If I now click on the button, you can see we have the laser. The reason it is up there is because, well, inside of the laser, we always are in the top left point and we don't update this position. Because of that, we always have the laser in this point and it's not moving. So we do have to make some updates, but it's certainly a good start. On top of that, what is another really powerful part of Godot? If I go back to the standard view, if the game is running like it is right now, so I can still run around perfectly fine, then you can return to the editor just fine. And you can actually look on the left. There is, besides local, where you can see all of the nodes, a remote tab. This is only visible when the game is running. And this shows you in real time what is happening inside of the game. So right now we have root. This is a technical part, but then we have the level. This is this level scene. Inside of there, we have the gate and we have the player. These are the two nodes we have added ourselves. But after that, we have the laser 4 times. And if I go back to the game and I keep on clicking, we add more and more lasers. So we can tell in real time, this is showing you what's going on in your game, which is incredibly helpful to debug your game. Also, when you click on them, you can look at the inspector and get a lot of information about what's going on. All of this updates in real time, which is super useful. Although in my case, I want to close the game because we don't need it right now. For now, there are 2 things I want to work on, and let me add comments. Number 1, the most important thing is we have to update the laser position. Right now, the laser spawns in the top left, and well, that's a problem. Number 2, we have to move the laser. That part should also be fairly obvious, and I do want to add a number 3, which is a bit smaller. I want to add the laser instance to a node 2D. Right now, we always add the laser to the level scene itself, which tends to get a bit messy because we just have a whole bunch of nodes in there. Instead, what is going to be much cleaner is if we add another node 2D that we could rename as projectiles. I want to add the lasers to this node. That way, the entire scene itself keeps much cleaner. But we're going to work on that in more detail later on. First of all, though, we want to update the laser position. And that, in the most basic sense, is actually really easily done. Because this laser now is also just a class. And we know how to update the position of a class. All we have to do is get the laser and then get the position. This position could, for example, be the player position, which means I can simply drag the player node in there and then get the position of the player. Now if I run the game, I can click and the laser is going to be on the position of my player, which is already a pretty good improvement, but not perfect yet. So instead what I want to do, and let me illustrate the problem. We are spawning the laser around the center of the player, so this red cross, which isn't realistic. Ideally, we want to spawn the laser somewhere from the position of the top of the gun. And for that, we can actually learn about another node and about some randomness, which are two very important concepts in Godot. So what I want to start with is I want to get a couple of random positions around the top of the gun. Around here, I want to have 3 random points distributed something like this. For that, we are going to need a marker 2D. Although this I want to organize because our player scene starts to get a bit messy. So inside of the player, I'm going to add a node 2D. This one is not going to do very much. It's just going to hold other nodes. I want to call this one the laser start positions. What is actually going to become important is I want to add another node, and this node is called a marker 2D. This marker 2D, if I hover over the center, let me show my mouse actually. If I hover over the center, we have a marker 2D, and this I can move. A marker 2D is literally just a position. You don't use it for anything else. If you look on the right, there really isn't too much. So let me put it roughly in the middle. That looks about right. Then I want to duplicate this node. So with the node selected, I click on Ctrl D, and now we have a marker 2D2, and this I move somewhere here. I can do the same operation again, and now move the final marker somewhere here. With that, I get 3 different points, and those are supposed to be my laser starting positions. Next up, inside of the code. First of all, when the player is clicking on the primary action, I have to randomly, let me add a comment, I want to randomly select a marker 2D for the laser start, which means I want to pick one of these 3 nodes, and that is going to be the actual starting position for the laser. Number 2, this is going to be right inside of emit. I want to emit the position we selected. When we are emitting the signal for the laser, we also want to emit the position. So there are 2 things we can work on. Let's start by randomly selecting one of the markers. For that, first of all, I want to get all of the markers inside of a list. That is going to make our life much easier. I'm going to store all of this in a new variable. Let's call this laser markers. To get the laser markers, first of all, I want to get the laser start positions. This is just going to be a node 2D right now. Although this node 2D has children. And these children we can get with the method getChildren. Once we have that, I can simply print the laser markers, and let's see what we get. If I now run the code and I click, we are getting a list inside of the output with 3 markers. We have marker 2D, another marker 2D, and a final marker 2D. This I also want to store in a variable. Let's call it var selected laser. And this should be a lowercase. To get a random item from a list, we first of all need the list itself, so laser markers. And I should say this is an array, not a list, but the difference is fairly minor. On that, we want to use indexing. For example, we could use index 0, this would give us the first item, or index 1, this would give us the second item. But we want to have a random item. For that, we will need random numbers in Godot, which always is a tiny bit weird. Basically what you have to do is use the function randi. Then we need the modulus operator, so the percentage sign that looks like this. And then we need the highest number, which in our case is going to be the laser markers dot, and this would be the size. And just to test if this is working, let me print the selected laser. If I now run the game again, I can click and I always get some kind of marker. There is some randomness, although since we don't have too many nodes, it's going to be a bit hard to see. But there you can definitely tell we get random markers. There are other ways to create randomness, but this is one of the more common ones you are going to see. You want the function randi, then the percentage sign, and then the highest number that you want for your randomness. In our case, the number here would be a 3, because there are 3 items inside of the list. And this would give us a number that goes from 0 up to 3, but not including 3. The possible numbers we could get would be 0, 1, and 2. And those we are then using for indexing on the laser markers. With that, I can get rid of the print statement and of the comment as well. Next up, I want to emit the position that we are getting from this selected laser position. And something like this we have already done. So I want to go all the way to the top. There we have the laser signal. This signal should contain one argument, which is going to be the position. Now that we have that, when I'm emitting the laser, this signal should contain one argument, which is going to be the position. Now that we have that, when I'm emitting the laser, I want to also, as an argument, include selected laser and then the position of this one node. That is actually all we needed. Now we are emitting a position. And this position we can capture inside of the level, because now onPlayer laser is going to contain one argument, which we can capture in a parameter, which is going to be the position. And this position we now want to use to set as the laser position. Let's try all of this now. If I click, nothing is happening. However, if I go back to Godot and go back to normal view and remote, you can see we have the lasers. And if I keep on clicking, we also can see we are generating more lasers. So the tooltip is a bit annoying right now, but if you look at the scroll bar, we are definitely creating more lasers. So this is working. Basically, the one change we have to make, we don't look at the position of the selected laser. Instead, we want to look at the global position. Now, if I run all of this, we can see the laser. And this one is working perfectly fine. Which begs the question, what is a global position and how does that differ from a normal position? Let's talk about it. So far, we always used a local position, and this position is always relative to a parent. We are basically measuring how far off we are from the center of the parent. A global position, however, is an exact pixel coordinate that is independent from any parent.
Okay. If I put the global position in the last type of code, like laser position equals player position plus any vector I want, it works on position and global position. If I emit the signal, it only works with global position. Why?
The way you want to think about it is, imagine you are sitting in your house right now. You do have some relative position to the center of the house. This would be your local position. But that being said, you still have, even in your house, a specific GPS location. And this position doesn't care about the position of your house. This would be your global position. To be a bit more specific for Godot, imagine you add a node 2D with an offset of x100 and y200, and you give this node a child on the same position. The child node would have a local position of x being 0 and y also being 0. That is because we didn't move it away from the parent.
Yeah, this is way better understanding. Okay. In this code, selected laser don't have position. Player have position. Okay.
However, it does have a global position of 100 and 200 because that is the actual pixel position. Understanding local and global positions can be a bit tricky, especially in the beginning. I suppose for now, just generally keep in mind.
I didn't understand the GPS example, but I understand the regular, not 2D.
that there
Exactly.
can be a difference. And just experiment with the two. Eventually, this should become fairly straightforward. With that though, we can return to Godot, because now we have the laser. And this is covering the first part. We have to update the laser position, so I can get rid of that. Next up, we have to move the laser. For that, I want to return to the laser, and now the laser is going to need a script. So I click on attach a new script. For the template, I want to go with empty, and for the folder, we are still in projectiles, so I am happy with that. I can click on create, and now we have a script. First of all, I want to define some kind of movement speed. Let's just call it speed. This is going to be an integer, and for the number here, let's go with 1000 for now. Once we have that, we are going to need a process function. All we want to do in there is to update the position of the laser. So I want to change the position, and all I want to do is I want to have some kind of direction, and this direction I want to multiply with the speed. And once again, don't forget, we also want to multiply all of that with delta. Now, the direction doesn't exist right now, and later on, we want to have the direction the player is looking at. For now though, I want to have a var direction, which is going to be a vector2, and the actual variable is simply going to be vector2 dot up. At the moment, the player is always looking up, so this is the only vector we need. I can now run all of this and shoot the laser, and we get a laser that is moving.
In PC, I hate when this happens. In Notepad, in anywhere else. Why? How? I don't know. But now, when I hit the space, deletes. Well, is this that easy? Okay. When you hit insert, it's go back to norm. Okay, okay. No problem. Let's move on.
This is looking really good. At this point, you probably want to experiment with the speed of the laser. And there's one really nice feature of Godot. When you are creating a variable at the beginning of the script, what you can do is add the keyword export. And this should be combined. It should be orange, then you know it's working. What this one is doing, if I return to the 2D view, and with the laser selected, I now get another parameter inside of the inspector. And this is giving me the speed, and I can update this. So let's say to 2000, and now if I run the game again, the lasers are moving a lot faster. All this export does is it exposes the variable to the inspector, so you can change it much more easily, which very often is really nice and makes the game much easier to update. Cool. In our case, this is covering another important part. We can now move the laser. Finally, I want to add an instance to laser to this projectiles instead of the level node. And this is super easily done. Right now, when we are calling this a child, we are calling the function on.
And if you do it like this marker 2D, I think it worked with the rotation as well. Right? If I rotate, no. Okay. It because vector 2 equals up. I wanna fix this. I wanna fix this. Hmm. I gave up. I don't remember how we do it. We did it in the other load game. I wanna see. Hmm, really? Is that it? Not it. Okay, let's move on.
On the node the script was attached to, which is this node 2D right now. I already have it selected. To add the child to another node, all you have to do is get the node itself. So let me drag in the projectiles and then run the method add child. Don't forget to actually add the child, which is going to be the laser, and then we are good to go. If I now run all of this again, click on remote, you can now see, if I move the game to the side, inside of projectiles, we have a drop down and we keep on adding more lasers. There's a bit of a delay, but it definitely works. Cool. With that, we have covered the final part. All we have to do now is do an exercise and then we are good to go. When this secondary action is triggered, I want you guys to create a grenade scene with a rigid body 2D. For now, the movement is going to be really weird, so don't worry too much about it. I'll cover that in the next part. Once you have that, create an instance of this node in the level scene and position it at the gun nozzle position. Basically, I want you guys to repeat what we did for the laser, except with the rigid body 2D. The major difference now
Fuck I did, bro.
is that it of a delay, but it definitely works. With that, we have covered the final part. All we have to do now is do an exercise and then we are good to go. When this secondary action is triggered, I want you guys to create a grenade scene with a rigid body 2D. For now, the movement is going to be really weird, so don't worry too much about it. I'll cover that in the next part. Once you have that, create an instance of this node in the level. The scene and position it at the gun nozzle position. Basically, I want you guys to repeat what we did for the laser, except with the rigid body 2D. The major difference now is that instead of a laser, we have a grenade. You can find the image for that next to the lasers in new scene. Like from project circling this, I think by default, this one is a bit large. It's even large, 0.2. Also now, I have to update the collision too small. Let's go for a scale of 0.4. Once again, we need a new collision shape. That's looking good. And now this feels much more appropriate. Now that we have that, we can work inside of the level script to create an instance of this scene once the player clicks on the secondary action, which triggers on player grenade. I guess as a reminder, when the player is clicking on secondary action, then we are emitting the grenade signal. And this grenade signal we are capturing inside of this function. First of all though, we have to create a laser scene. Like we have done for the preloads. Once you specify scene, then I meant you to do so. Although to simplify things a bit, I want to positions. On that, I want to get the children once again. And on that, I simply want to pick child number 0. Finally, we have to add this new grenade to the node tree. And for that, I am going to reuse the projectiles node 2D. So I want to get projectiles and then add a child, except now the child is going to be the grenade. And with that, I can run all of this. If I now click with my right mouse button, we get some weird behavior. We do get a grenade, but, well, it's falling down. And that's a very weird behavior. The lasers, though, still work just fine. And this part is getting really long, so let's finish it here. And in the next part, we talk more about rigid body 2Ds. If you understand them, they're quite easy to work with, but if you don't, they're really frustrating. Let's cover the final collision body, which is a rigid body 2D. On top of that, for this part, we are also going to cover the player rotation. That way, we can shoot in different directions, something that is very much missing right now. But first of all, a reminder, here are all of the collision objects.
Let's see what I'm doing wrong, because I can't get the rotation updated.
At this point, we have covered an area 2D in detail, we have covered static body 2Ds, and we have a character body 2D. So the only thing missing is a rigid body 2D. And as a reminder, this is a moving body that moves via physics. It's basically a cannonball. We already created the grenade, so we already have some pretty good starting points. However, if I go to Godot, I can already show you as a reminder that right now the grenades are acting really weird. So what's happening here? The issue is that a rigid body 2D has a gravity setting, which by default is set to 1, which means it is falling down, which is the issue we have to deal with right now. Besides that, you can also set physics behavior in the inspector, and there are additional options that you set via a physics material. I'll cover those in just a second. Finally, you are only supposed to give this rigid body 2D a starting velocity. All of the other movement is handled by physics. And that, once again, is quite a bit of theory, so let's have a look at all of this. Back in Godot, I want to have a look at the grenade, and on the right, we have the inspector. Right now, the major issue that we have is this gravity scale. This is set to 1, and this means that things are moving down. If we set it to 0 and start the game again, I can now shoot a grenade, and it doesn't fall down anymore. We also get collisions, but that's just about it. Nothing else is happening. Basically, with this setup, we have a static body. So how can we actually change things? For that, you would want to look down a bit, and there we have linear and angular. Linear is the easier one, and there, for example, we have velocity. This is the movement of this rigid body. There we have x and y. For example, if I set x to 100 and run all of this again, then we have a movement to the right. And this works for all of the objects we are going to create. So this is working just fine. Also, we get collisions, looking pretty good. You can set a few more things in here. For example, there's angular velocity, we have constant forces, but I don't worry too much about those. Instead, what I want to work on is the physics material. And expand this a bit. We have a physics material override. Right now, it says empty, but if you click on it, you can give it a new physics material. And this gives you a few more options. And in particular, bounce in there is an interesting one. For example, this we can set to something really large, let's say 100. And now if we run the game again and we get a bounce, there the grenade is bouncing off our player. We can do this a couple of times. Let me create another grenade. And there we get another bounce. If we set this to a lower number, let me set it back to 0. And we do all of this again. Now we get a different kind of bouncing behavior. All of these numbers depend very much on the mass, the inertia, then the physics material, and then all of the other stuff you can set in here. If you want to have really good physics behavior, you want to play around in this a lot. Although in my case, I'm not going to worry too much about it. Instead, what is much more important right now is that right now we always shoot the grenade in one direction. So right now, this would be to the right. But this obviously doesn't work terribly well. So we have to figure out how to control the starting direction of this grenade. And for that, once again, we will need some code. Although first of all, I want to minimize the physics material. If you click on it, you can maximize and minimize it. And I want to set the velocity back to 0. Once we have all of that, I can have a look at the script, and we are creating a grenade inside of the onPlayerGrenade function. Right now, we are only setting a position. What I also want to do is get the grenade again, and then set a linear velocity. Right now, Godot doesn't autocomplete this line, and there's actually something super useful I can cover right away. We know that this grenade is a rigid body 2D, and a rigid body 2D, if I open the inspector, has a linear velocity. So it should come up in the autocomplete. However, it doesn't. So if I type linear, nothing is happening. The reason it doesn't is because Godot doesn't know that this grenade is a rigid body 2D. But we can give Godot a hint, or rather we can tell to instantiate this object as a rigid body 2D. That way, the grenade now is going to get a linear velocity, which is much easier to work with. You don't have to add these things, but very often in game development, or in development in general, you want to be really precise about the types of data you are working with. So adding this S can be super helpful. But anyway, this linear velocity wants to have a vector. Let's just give it one, and let's say for now, we want to have a vector 2 that is always pointing up. So we always shoot north. This we can multiply by a speed, let's say for now 100. What this one is going to do is now the grenade is going to move up. The grenade we had by default in the scene is not going to get this attribute. So as a reminder, let me minimize this. Inside of the level, I have created one grenade to test the scale. And this one we are just adding as an instance inside of the editor. However, inside of the script, when we are creating the grenades, we are updating the position and the linear velocity, which means the grenades we are creating inside of the function are going to move, but the one we created just here is not going to move. I hope the difference here makes sense. You could also work with different directions now. For example, this could be left, and let me run this again. Now we get a grenade moving to the left. So this is still working just fine. That being said, we don't just want to have a hard-coded direction, we want to shoot in the direction the player is looking at. And for that, we have to add a few more things. First of all, we have to start with the player. So right now, the player is always looking up, and this obviously isn't ideal. Fortunately, we can change that super easily. Inside of the process function, I want to add another entry. Let's call it rotate player, or just rotate. Basically, what we want to do is we want the player to always look at the mouse. Meaning if the player is somewhere here and our mouse is somewhere here, we want the player to rotate and look at the mouse. For that, Godot has an inbuilt function that is incredibly helpful. This one is called look at. And this look at function is rotating any kind of node so it looks at a certain vector. You can see it in the prediction, we get point vector 2. The point we want to look at is our mouse position. And this we can get very easily. We need another function that is called get global mouse position. And that is almost all we need. At this point, I can run the code and we're going to get something weird. You can see my mouse and the player is rotating, but it is rotating in the wrong way. So we basically have a 90-degree offset. The reason for that, and let me minimize all of this and explain things a bit more. So here is the player. We want the player always to look at straight ahead, and let's say here's the mouse. This would be the ideal. Right now, however, the issue is that the player always rotates in roughly this direction. So what's going wrong? The answer for this one is actually quite easy. The default rotation for a vector is always going to the right. So this is the default 0 position. And since our player currently is looking up, we are giving it a negative 90-degree offset, which is what's causing the problem inside of the game. To fix that, we have to get our player image, then go to transform, and then rotate all of this by 90 degrees. And now we have to realign the player with the collision shape, and this should work much better. If I now run all of this again, there we get a much better behavior. So this I am quite happy with. Although now, if I actually click on the mouse button, we get some weird laser spawn behavior. Same with the grenades, this doesn't work terribly well. The reason for that is now we have the gun nozzle here and the laser starting positions are here. That fortunately is quite easy to fix. Let me zoom in a bit. All we have to do is take the markers and move them in the new position. It doesn't have to be too precise, but try to get it something like this. With that, I can run the game again, and now we get a laser from the top of our gun. Same with the grenades, and this is definitely an improvement. Cool. However, now we have another problem, and that is, you could already see it, the lasers always go up and the grenades always go to the left, which means we have to add a few more things. And let's start with the grenade. And sending the signal, I actually realized I forgot to add the position. Down here, when we are emitting the signal for the grenade, we already included the position. And this still works even if you don't add it, but it's better form to include it. I want to include a position, and besides that, I also want to include a direction. This direction we have to get. All of that is going to happen inside of the secondary action if statement. I, besides a position, want to emit this direction we have to get. All of that is going to happen inside of the secondary action if statement. I, besides a position, want to emit a direction, which doesn't exist right now. So we have to create it. Let's create another var direction. So what are we going to need for the direction? Well, what we are going to need is some vector math. We basically want to figure out, and let me draw all of this. Our player would be somewhere around here. The actual position doesn't matter so much. And then we have a mouse position, and what we want to know is the direction. So what is this angle going to be? And for that, some very basic vector math is going to be what we need. And let me simplify the drawing. This is our player, let's call it P, and then we have the mouse, let's call this one M. That is the worst M I've ever made. That should look more like this. To get the direction between two vectors, you always want to have the target vector, which in our case is the mouse position, and from that you want to subtract the starting vector, which in our case is the player position. Which means all that we want to do, we want to get, once again, get global mouse position, and from that we want to subtract the player position. The position of the player we can get quite easily. This is literally just a position. Because remember, this script is attached to the player. So a position is just the attribute of the player. And with that, we have a good start, although Godot is complaining. There is already a variable named direction declared in this scope. As a consequence, we have to rename this direction. Let's call it player direction. And this is the direction we want to emit when we are emitting the grenade signal. That being said, there's one more thing that we do have to do. This outcome, which is going to be a vector, we have to normalize. What does that mean? Well, back to the drawing, and let me clean all of this up once again. Let's say the player position is at 200 for X and 1.
It's normalized. Them are videos. Come on, dude.
For Y. This is just the position. And the mouse could be at something like, let's say, 300 and 200. If we subtract one from the other, the operation we have done down here, all that we're doing, we are getting our target vector, which is 300 and 200. And from that, we are subtracting 200 for X and 100 for Y. The result would be 100 and 100. What these numbers mean is that we have to go 100 pixels to the right and also 100 pixels up. And that's why we get from one point to the other point. Now, these numbers are useful for the position, but for a direction, they are useless. Because what we want to do in just a second, is we want to multiply this with a speed. For simplicity, let's say our speed could be 500. The result of all of this would be a huge number, way too large. Also, it would be inconsistent. If the mouse, so this point, is further away, let's say it is at a position 1500, we would get 1000 and we would get 500. And from that, we would be once again subtracting 200 and 100. The result would be 800 and 400. Having these two numbers being different, this direction and this direction are inconsistent. The outcome would, depending on how far away the mouse is from the player, we would get faster or a slower movement. So I hope all of this makes sense. Basically what we want to do is we want to normalize the direction. That we only get the direction, but not the length of this vector. And for that, we will need normalized. This is a really common operation you do in game development. It reduces the size of the vector to 1, which would turn the length of this vector and this vector identical, so that when we multiply it with a speed, we always get the same outcome. Okay, there was a lot of explanation for not very much code, but this is what we need to get the direction that the player is currently facing at. This we can now use inside of the level, because there we have onPlayer grenade. Besides a position, we also get a direction now. And this direction I want to use instead of the vector.left. So direction, and now this should be direct. This we can now use inside vector2. And for that, we will need normalized. This is a really common operation you do in game development. It reduces the size of the vector to 1, which would turn the length of this vector and this vector identical, so that when we multiply it with a speed, we always get the same outcome.
Yeah.
Okay, there was a lot of explanation for not very much code, but this is what we need to get the direction that the player is currently facing at. This we can now use inside of the level, because there we have onPlayer grenade. Besides a position, we also get a direction now. And this direction I want to use instead of the vector.left. So direction, and now this should be working much better. So I can shoot a grenade, and I always have to wait 2 seconds, but now it moves in the right way. So this is looking much better. One more thing that I do want to do. Right now, the speed is always 100, and that I don't like so much. Back at the grenade, I want to add a script. And the script, once again, I want to have in the same folder where we have the scene. This one is looking good. And for the node, I want this to be empty. So create, and now we can set var speed, and let's go with 750. Although this doesn't have to be a variable, this can just be a constant because it's not going to change. With that, back inside of the level, and once again, I want to extend all of this. I want to get the grenade, and this now has an attribute, which is going to be the speed. Let's try all of that again. It is working. Well, the grenades are moving faster. So that's a good sign. Although there's one more thing that I do want to do. So let's say I hit a wall, something like this. Right now, the grenades stick to the wall almost perfectly, but that I don't like so much. To overcome that, I am going to work inside of the inspector, inside of the physics material. I'm going to set the friction to 10 and the bounce to 0.4. Besides that, under linear, we have damp, and this I want to set to 1.6. With that, if I try all of that again and hit a wall, we get quite a bit more bounce. That I do like a bit more. Also, when we hit other rigid bodies, we get basically billiard. So if you want to make that kind of game, you now have a really good start. With that, we just have to do an exercise, and then we are done with another really important bit. I don't think we have to practice with rigid bodies too much, because they're ultimately not that complicated. However, what I do want to practice is the laser, and this is the one part of the game that we definitely have to work on. I want you guys to move the laser in the player direction. like we have done for the grenade. Pause the video now, try to
I will be so mad if this works easy. Ah.
implement this one. I want to look at the level, and in there, first of all, I want to get rid of the grenade because this one shouldn't be there in the first place. Now we can work on the laser. This part just annoyed me. Okay, so for the laser, we have to look at some code. We are creating a laser in the onPlayer laser function.
Man, try and fail, and finally something is fixed.
And this one right now only has a position. Besides that, we also want a direction. This direction we have to generate inside of the player. And for that, let's look at the player. Inside of this if statement, we are generating the laser action. So this one will also need the direction. I'm going to put this right below the other variables, but you can basically put it wherever you want. Once again, I want to create a player direction. This player direction is going to be a new vector, and for that, I want to get global mouse position and then subtract the current position of the player. All of that we also have to normalize, and then we are good to go. One important thing to mention now is that we now have a player direction inside of this if statement and another one inside of this if statement, which, well, is a bit unnecessary. We can simplify this by simply cutting out the first one and then placing it before the if statements. That way we don't need the second one anymore. Next up, when we are emitting the laser signal, besides the position, I also want to get the player direction. On top of that, all the way at the top, right now, when we are declaring the signal, we only have the position. Now, all of this would still work, but nonetheless, you want to add the direction in there for one important reason. If I minimize all of this and go back to my level scene, in there we have the player, and the player has two signals. We have the grenade, and this one shows the position and the direction. However, the laser only has the position right now. And it shows the position because inside of the script for the player, we only have the position. If I add the direction and then save all of this, we now get laser, position, and direction. So this makes it much easier to see what's going on in your game. You could leave all of this entirely blank and it would still work, but if you work with anybody else, or if you are not looking at your game for some time and come back to it, this would become incredibly confusing. Adding these parameters here is really good documentation of your code. But alright, with that, we have a laser signal and we are emitting the position and the direction, which means now inside of the level, we are getting the position and the direction. So now inside of the laser, we can use all of that. For this one, we want to get our laser, and now we have a bit of a problem because for the grenade, so the rigid body 2D, we could use the linear velocity, but for the laser, such an attribute does not exist. And just to be consistent here, it's going to be an area 2D. So what can we do to move the laser in a certain direction? Well, all we have to do is once again get our rotation degrees. To get the rotation degrees, all we have to do is get the direction and then use the angle method. Any vector in Godot has this method. It simply converts a vector to an angle. However, it returns radians, not degrees. So you can make an adoption in one of two ways. Either you could wrap all of this inside of another function, and the function you want is called rad_2_degree, or just deg. This converts a radian to a degree. Alternatively, since the rotation by itself is looking for a radian, this would also work just fine. However, if I run all of this now and I shoot, we get some slightly weird behavior. So this is not ideal. The reason for that, if I open the laser scene, you might already see it. By default, the vector position for 0 goes this way, but our laser points up. Because of that, our direction is wrong by 90 degrees. Now, you could rotate the laser, but in my case, since I want to demonstrate a couple of different approaches, we can do something different. Back inside of the level, I want to expand all of this. I once again want to use rotation degrees because that's going to make the math easier. And I want to convert the angle we get from the direction and convert this with rad to degree, like so. All we have to do is add plus 90, and this would also work. So let's try this one. And now we get a better behavior. So the laser is pointing in the right direction. It's just not moving in the right direction. It always moves up. But we certainly make progress. The reason why the laser is always moving up, let's have a look at the script. We have a direction that is a vector 2, and this one is always going up. So this vector we have to change, which we can do inside of the level. I want to get the laser, and now one attribute is direction. This is the direction we have declared here. And this direction is just going to be the direction we are getting from the player. So the one we are getting via the attributes. And now this is feeling drastically better. And with that, we have our laser. And it's working.
Mine is
Really
better.
good. This is feeling drastically better. And with that, we have our laser.
I didn't change the 90 degrees. I get the laser's rotation here. I get the laser's rotation in here. No. This works first. I get a global position and global rotation for selected laser. Then this works. Setting this laser's position and rotation. What if I do this? Nothing changed, I guess. Laser rotation equals rota. Laser position equals position. Position is selected laser global position. This is selected laser global position. What the fuck is this? And why it don't work on here? Interesting. Why this work here, but not here?
And it's working really good. Cool. So with that, we have covered another really important part of Godot. At this point, you should have at least a basic understanding of the different physics bodies and also how to create instances of a scene in code, which is super useful to create bullets or lasers or stuff like that. For this part, we're going to cover something surprisingly easy, the camera. All we have to do for that is to add one more node to our player, and then we are done. There's no theory to cover here, let's jump right in. Here we are back in Godot, and if I run the game, you can very much tell there just isn't very much space. All of this feels incredibly cramped. So what I want to have is a camera that follows the player, which would enable us to actually explore the level. And for that, like basically anything else in Godot, we have to learn about another node. That node is called a camera. And I want to add a camera 2D, another outline. Now if I run the game, we already get some very different behavior. It's as easy as that to add a camera. However, at this point, if I move around a tiny bit, you can see there's some weird jankiness. If you follow along, just move around yourself. It doesn't feel very natural. That is because the camera 2D is lagging behind the object it follows. It's not a perfect one-to-one movement. Instead, there's supposed to be some smoothness. That smoothness you get under position smoothing, and you basically always want to have this enabled. Otherwise, your game is going to look quite weird. You can set a speed, although 5 pixels per second is usually what you want. Now with that, if I run all of this again, now our game is feeling much better. And if I stop the movement, you can see the camera is catching up to the player very, very quickly, but there definitely is some kind of movement swing after we stop moving. And with that, we have a camera that's actually looking good. Now, another thing that you probably want to do is set the zoom level. This tells you how big this rectangle is going to be, so the actual visible area. For example, we could set this to 0.6. And now you are going to see much more of the level. And this is what I think I used for the final game. So this is what I quite like. Other than that, you have a few more attributes you could be working with. For example, you could give the camera an offset. And if I set this to, let's use a larger number, 300 pixels, you can already tell now the camera is being offset by 300 pixels. This would also be visible in the game. Let's run all of this again. And there we go. Now the player is always at the top and the object or the gate is still there. There are a few more things you could work with, but most of them aren't terribly important. I guess rotation could also be an attribute, but in our case, the player isn't going to rotate. So all of this gets much easier. The last attribute you might be interested in is the limit. And this tells you how far the camera is going to go. For example, if I set the left side, which right now is at minus 10 million, if I set this to 0, you can already see it in the game. Now the camera cannot exceed the left side of 0 pixels. 0 pixels is this side, and our camera can never exceed it. So now if I run the game, you can see our camera is never going further, and if I go up and you see the gate, you can actually tell what's going on. So our camera can never go further to the left, but we can still go further to the right. Cool. Now in my case, I don't want to have this enabled, and I also want to set the offset to 0. But these are options you might find interesting. But other than that, a camera really isn't terribly complicated, so there isn't that much you have to know about it. But before I finish this part, there's one more thing I do want to cover, and that is the actual size of the game. So right now you can see we have this blue outline around our game, and this is telling us how big the window is. And this you can change quite easily. This happens inside of project and project settings, and in there you have lots of options that can determine how the game is run on a computer. The option you want to look at is under display, and there we have a window. Right now, we have a window size of 1152 and 648. I have no idea how we get those numbers, but you can change them quite easily. In my case, I'm going with 1280 by 720. Those feel like much more natural numbers. You can also set a whole bunch of other variables, but in my case, I'm not going to bother too much. Also, if you have a larger window, you could set larger numbers. Just choose whatever you think is best. So with that said, let's run all of this again, and now we get a slightly larger window. And that is all we need for this part. The camera ultimately is a really easy thing to implement. Now that we can move around, it is becoming a bit obvious that our level is just not looking very good, simply because we don't have that many images. So what I want to cover in this section is how to display lots of images. Or more specifically, we want to decorate the level with images. And there are a couple of ways you can approach this. The easiest one is you can simply place a lot of sprites and then modify them quite a bit. You can do that either by changing the scale or the color values. And this is what I want to start with. Although I already want to emphasize, for any kind of complex setup, this is not going to be good enough. For that, we're going to use a tile map. That I will cover in just a bit. For now, let's place some sprites because they can do quite a bit. Back in Godot, we can see that we have a gate and a player. Those are the only things visible, which isn't very much, and that's the main reason why our level doesn't look very good. To make all of that a bit prettier, with the level node selected, I want to add another node. And this, for now, is going to be a node 2D, which I'm going to rename right away. Let's call this one the ground. And this ground should be below everything else, so I'm placing it before the gate and the player. This ground for now is going to get a sprite. I want to rename this one right away as well. Let's call this one the soil. Now that we have that, I want to go to graphics, and in there we have a folder called ground. There we have dirt, mesh, and stones. Stones is the one I want to use, so I'm going to drag it into the texture tab, and now we get a texture. Let me move it a bit around. And with that, if I restart the game, this is already looking a little bit better. Not that much, but it's certainly an improvement. For now, the major issue is that this texture is ending quite quickly. So this isn't ideal. Which means now we have to figure out how to extend this texture. And the first thing you could be doing is, if you go to transform and look at scale, you could scale this by a factor of 100. And, well, you would have technically an infinite texture, or at the very least a really large one, but it would look really bad. So this isn't acceptable for a game. That being said though, if you scale it to something, let's say a factor of 5, this would still be looking fine. So this is definitely something you can work with. But in my case though, I don't want to use this scale at all. So I'm going to set it back to 1. Instead, I want to use the region. And we have seen this all the way at the beginning of this tutorial. So if I enable it, by default, the texture is going to disappear because we now use a rectangle that has an X and a Y position and a width and a height. By default, all of these are 0, so we are showing nothing of the texture. But we can edit the region with the Edit Region button, and there we can select what we want to show of this texture. We could, for example, simply pick one part of it. And there you can see inside of the game, we get this texture inside of the game. What we can also do is we can select a larger area. And let me select a much larger area. Something like this. And now we have, well, a larger texture, but it looks absolutely horrendous. And that is because Godot is stretching out the border pixels, which is not a good behavior. We can change that though. And this we do under texture, and there we have filter and repeat. Filter tells you when you are scaling the texture, how is it going to scale, which in our case, we're not going to touch. Repeat is what we care about, because in there we have inherit, disabled, and enabled. Enabled is what I want, and this is looking much better. With that, we get an actual texture that we can use basically infinitely. So let me run this again. And if you look very, very, very closely, so let me close the game, and if I zoom in, you can tell there we have repetition marks, which are quite fine, and for our game, they probably wouldn't be noticeable. And in an actual game, you could simply place some other object on top of that and then not worry about it. Also, if you zoom out, it's barely noticeable. So this is totally fine for a game. That would be the first way you can work with your level to add more images. And this is a really good start. So now, at the very least, we have some kind of background. Although I do want to add a bit more. So with the ground selected, I'm going to add another sprite node. And this sprite node, I'm going to call it decoration. The texture for that we get from decals, and there we have a dirt patch. This I want to drag into the texture, and now we get something like this. It's just a texture that is displaying some dirt. I think it's quite straightforward. And this one doesn't really fit into the background we have right now. So if you look at it inside of the game, I guess it kind of fits to an extent, but it could be better. To make this kind of thing look better with the decoration selected, you want to go to visibility, because there you have visible, this one should be obvious, but then you have modulate and self-modulate. And by default, they are showing a white color. And this one changes the color of this sprite texture. For example, if I change it like so, you can see we get some other kind of color. You can also change the transparency and then make it disappear or reappear. And in my case, we could make all of this quite a bit more orange. Although you would have to play around with this quite a bit to make it look really fitting. And I just don't have the time inside of a tutorial. So let me do this a bit more roughly. I just want to wash it out so the color fits better. I guess this one fits slightly better. It's certainly an improvement, so I am reasonably happy with that. You might also be wondering, why is there modulate and self-modulate? What's the difference between the two? And if you hover over them, you can already get the answer. If you look at modulate, we got the color applied to this canvas item. This one should be quite obvious. The more important part comes next, and that is that this property does affect child nodes. Unlike self-modulate, which only affects the node itself, which basically means that if this node has children, they would also be affected by modulate. However, self-modulate only affects the node itself, which means if there are children, they would be ignored. That's the only difference between the two. Cool. And with that, we have some more upgrades. I guess what you could also do is there's quite a bit of moss, and you could just drag it into the scene. Let's say like so, like so, like so, and just zoom in. There we get just a couple of moss images, and all of these moss images I want to have inside of the ground. That way we keep everything organized, which is really important for a more complex game. And well, these are once again just images you can move around. They don't do very much. So with that in place, let's play the game, and there we get more and more details. For an actual game, you basically want to keep on adding more images and then flesh out the game. The more you have and the better you get at placing them, the better your game is going to look. Although this kind of thing is really time intensive. So if you want to have a really good looking game, you will have to spend a lot of time working with these sprites. In my case though, I'm happy with this, and I think all of this is reasonably straightforward, so we don't have to practice it. Instead, there's something that I really want to cover, which is significantly more important. That topic is going to be tile maps. To explain what they are doing, let me show you an image. Here we have a couple of walls. And a tile map is dividing these into certain areas. You can set the size yourself, and when you design artwork, you want to keep this kind of grid in mind. And once we have this kind of grid, we can pick items from that and then place them in a certain position. For example, we could make something like this, where we take specific parts of the wall. For example, we are starting with this part and place whiting some sort of name each individual. Finally, tile maps in Godot, we have a tile map. And this is a Godot node that organizes tile sets. It can contain a single one, but it could also contain multiple. Tile maps in Godot are fairly powerful, so I will spend quite a bit of time on them. But with all of that covered, let's jump into the editor, and for Command A, I want to add a tile map. If I add that, nothing is going to change in the game, but inside of the editor, we are now getting a tile map. This one contains a few tabs. We have tiles, patterns, and terrains. Although right now all of them are empty, so we can't use any of that. To make something work, we have to look on the right in the inspector. There is a tile set. Right now, this one is empty. And to create a new tile set, we have to click on empty and then new tile set. If I click on that, not much is going to change. Although at the bottom, we now have a tile set and a tile map. The basic separation between the two is that a tile map lets us use a tile map and draw things inside of the game, whereas a tile set contains the graphics and lets us edit them. For example, in there, we could rename things, or we could add physics behavior and quite a bit more. I'll cover that in just a bit. First of all, though, I want to click on the tile set again. So inside of the inspector, I want to click on this tile set, because in there, we get a few more options that are really important. Tile shape and tile size are the really important bits. Tile shape right now is square. Although besides that, we could also have isometric, half offset square, and hexagon. In our case, we want to have a square. And the square size we are setting in the tile size. But versatile, this is definitely helpful. Although before we continue, let me explain what these numbers mean really quick. Here's the slide from earlier, and there are two attributes that we need to set. The first one is the shape of each tile. If I could draw of 190 by 390. With this quite a bit. If the size or the shape doesn't line up, none of this is going to work properly. And essentially what Godot wants is that we are dragging a graphic. The one you have seen in the slides is called outside walls. This I want to drag into the tile set, like so. And then we can already see the graphic. First of all, though, Godot is giving us a message. If I expand this, it says auto-create tiles in non-transparent texture regions. Basically, what Godot wants to do is to create a tile in all of the tiles where we have some kind of graphic. This I do want to do, so I'm going to click on yes. And with that, let me expand this field by clicking on the icon. We now get a selectable graphic in all of the tiles that have a graphic. So those two at the bottom don't have anything, so I have to click on them to activate them. And if I right-click on them, I can delete them again, which unselects them. Which is the behavior I want, because those two tiles are going to be useless. I don't need them. Now we have a tile set. And this tile set right now, we can change. This, for example, we could do inside of this field. We could, for example, change the name. Right now, the name is the name of the file, which isn't ideal. So let me rename it to walls. That seems a bit better. You could also change the margin or the separation. Let me change the separation to 50. Then you can tell we have a gap of 50 pixels between them, which is very much not what I want. But if you have some kind of graphic where you don't know the tile size, you do want to play around with them quite a bit. You could also, if you look at the top, select the tile. So if I click on select, we get a few more information. For example, we could add an animation, we could change the rendering, but I am not going to do any of these things. What I am going to work on later on, though, is the paint tab. In there, we can paint properties. And the properties we could paint are quite diverse. For example, later on, we're going to add a physics layer, which is telling Godot that we want to have collisions with all of these sprites. But this is going to come later. For now, inside of the setup, because I changed the properties, some of these tiles are unselected. So I want to click on them to make them available again of these, but is you can tile click on them tiles in non-transparent texture regions. Yes, graphic. So, and with that, let me expand this field by clicking on the icon. We now get a selectable graphic in all of the tiles that have a graphic. So those two at the bottom don't have anything, so I have to click on them to activate them. And if I right-click on them, I can delete them again, which unselects them. Which is the behavior I want, because those two tiles are going to be useless. I don't need them. Now we have a tile set. And this tile set right now, we can change. This, for example, we could do inside of this field. We could, for example, change the name. Right now, the name is the name of the file, which isn't ideal. So let me rename it to walls. That seems a bit better. Which is if you look at the top, select the tile, what up. All I have to do is select one of these tiles, then click on the level and make a larger. I can paint these tiles and create a wall, for example. I could make this even more elaborate and make a larger wall that has a corner, something like this. And with that, we have a wall. I can run the game now, and we can see the wall in the game. This is looking really good. So I am quite happy with this one. Although the actual wall I don't want to have like this, so I want to delete the tiles. For that, I simply have to right-click on the tile and then it gets deleted. Instead, what I want to do for now, since the player isn't supposed to get into this area in the back, I want to create a wall, let's say roughly here, and then move around. I guess we can place one more here, and then on the other side, we could start a wall, something like this. And since the player isn't going to see this part here at all anyway, we don't have to worry too much about what the graphics look like. So I want to have a few more walls, and you definitely want to play around with this and spend some time on it, but this for tutorial is totally fine. So now let's run this again. And now we are seeing a wall, and right now there's too much of a gap, so we do have to work on that. I guess later on I could add, for example, another kind of object in there, but the wall otherwise is working just fine. This is covering the absolute basics of a tile map. That being said though, tile maps are really powerful, so there's a lot more to cover. I guess what I want to start with the tile set selected. I want to add another tile set. Right now we have walls. Besides that, I want to have soil. So this I also want to drag in there. And then Godot is asking us once again, do you want to auto-create tiles? And this I do want to do. Now we have a second tile set. I want to rename this one as well. Let's name it soil. And this is just about all we have to do in here. There isn't that much more, and this tile set is quite simple. So we just have a couple of dirt textures, basically. Those I can also use inside of the tile map. So now besides the walls, we have the soil. And this soil I can also place on the map just fine. So this one works just as intended. However, we do have a problem now. If I place the soil tile in the same tile where I have the wall, we can see we are deleting the wall, which is very much not intended. So let me undo it. And instead what I want is to have these soil tiles always below the walls. And to achieve that, I have to work with layers. So there, on the tile map, we have layers. Right now, we only have a single layer. And this I want to give a name right away. Let's call this one the walls. And if I type in here a name, you can also see we have walls in this tab as well. This is really important. Keep this in mind. What you can also do is add another element, which is what I want to do, because besides the walls, I also want to have soil or ground or whatever you want to name it. With that, we have two layers. And the order of these two layers is really important. Whichever layer comes first is going to be below the other layer. This works kind of like what we have seen with the nodes. So in our case, we have the wrong behavior right now, where the soil is on top of the walls. And this you can change quite easily. All you have to do is pick this icon on the left, the three lines, and then move it where you want it to be. So now we have the soil below the walls. Which means now, whatever we are placing inside of the soil layer is going to be below the walls. And these layers you select with this tab, where we have soil and we have the walls. And if you select one of them, right now all of our tiles are inside of the walls layer. So from this, I want to get rid of all of the soil. Which means at this point, I only have walls on this layer. But if I select soil, these walls become a bit more transparent, which is indicating to me that we don't have them in the current layer. And instead what I can do, I could, for example, draw below them a couple of tiles with soil. And let me do it like this, so all of this isn't looking too bad. Now, if I once again select the walls, we can see that the soil, this is a bit hard to see, but the soil is now blacked out and we can see the walls again. And if I unselect the entire tile map, we can see we now have quite a nice looking graphic. And below that, we have tiles with the soil. This also works in the game. And if I walk over there, we get quite a nice looking graphic. So this is looking really good. What you can also do with the tile map selected again, on the right side, it's going to be quite annoying to draw all of these tiles. So if I simply want to paint this one area, selecting every single tile is going to be kind of annoying. And for that, Godot has a couple of features. So right now we have this pen selected, which says paint. On top of that, we could also draw a line. With this one selected, I can simply draw a line, and Godot is drawing a line from one point to another. What is a bit more useful is the rectangle. This one allows you to draw a rectangle, which is drastically faster. You also have a fill bucket, and this one intelligently fills a certain area. Although this is not what I want to use right now, because, well, we don't want to fill every single tile. The way you would want to use the paint bucket is you want to draw an area of tiles, let's say something like this, and this needs to be enclosed. And in there, you can fill the entire area. Although this is not what I want to do right now. Instead, I want to draw in the corners of this area here. So something like this. And there I realized that right now I am working on the walls. I should have been working inside of the soil. Which means I want to get rid of all of the tiles I have just created. This shouldn't take too long. There we go. And now with the soil selected, I want to draw a couple of corner pieces like so, like this one, like this one. For the downward pieces, I can use those. And then at some point, I'm going to go back to the right. Now, for this one piece, we have a bit of a problem because we don't have a corner piece for this particular area. Instead, I'm going to place a tile like that. And this wouldn't work in the game because you can see the transition from one tile to the other is looking pretty bad. To hide that later on, I'm going to place an object on top of that. If the player can't see it, it basically doesn't exist. So we don't have to worry about it too much. And now if I zoom out, I can close this area, something like this, and then fill the entire thing with a paint bucket. With that, let me try the game, and I can still shoot the laser. That's a good start. And there we can see we have a wall, and the wall should probably be a bit longer. And on the right, we can see we have certainly an improvement, although we do have to extend the soil, and we have to later on hide this corner. First of all, with the soil selected, I want to click on region and edit region. With the editor selected, let me maximize the window. I want to expand this window as much as I can. And this, if you make it too large, can be a bit annoying to work with, but I think something like this should work. And there we go. Now we have a really wide level. Obviously, if you have your own game, you want to be a bit more specific here, but I think for my purposes, this is fine. I guess inside of the editor, we can change this from 25,000 to 22,000. That's looking a bit better. Let's say 20,000 pixels. That looks about right. Later on, we're going to constrain the player to roughly this area. That way, whatever happens outside of it doesn't really matter. But you don't want to have a graphic too large because that's going to affect performance, at least a little bit. I guess we could turn this to 16,000. And yeah, that feels a bit better. And for the height, I want to have 10,000. And next up, we have to hide this ugly corner. And I suppose a good way to approach that is to simply drag some of the moss and then place it in that position and make sure it's on top of the tile map. And that is looking a bit better. I guess to make all of this look more realistic, we could take all of the moss and place it on top of the tile map. That's not what I meant to do. Something like this is better. And now we can simply have some moss along this tile map. And if you duplicate the nodes, you can add a lot of stuff in there quite quickly. Then I want to duplicate all of this with transform. I want to give it some rotation, move it there, and I can do this multiple times and simply add more and more tiles. Once again, the more detailed you add to your level, the better it is going to look, at least as a general rule. Finally, this wall is too short right now. So with the tile map selected, I want to work inside of the walls and add or paint a few more bits there. And this is not what I meant to do. There we go. And all right, with that, we have a much better looking level. This is a significant improvement. All we have to do now is do an exercise, and then we are done with another major part. I want you guys to create a new scene with an area 2D as the parent. The name of this scene should be house. Next up, I want you guys to add a tile map as a child and then use the interior.png graphic to create images for the house. To make all of that, you will need 3 layers. You will need the floor, then the outer walls, and then the interior walls. The order of this also matters. The floor should be at the bottom, next up you have the outer walls, and then the inner walls. I suppose I should explain the tile set first of all. Let's have a look really quick. Back in Godot, I am going to click on the interior.png tile set. There I can expand things a bit. We have lots of tiles. The ones for the floor are these. The outer walls are those, and then the inner walls are these ones at the bottom. You will have to play around with this for a bit, but I think once you have a bit of practice, this should be a fairly straightforward tile set. So pause the video now and try to figure
I need to add this. Okay, create a new scene with an area 2D as the parent, call it house, add a tile map as a child, and use the interior PNG graphic to create the image for house. Okay, let's finish this. And call it a day.
this one. This is a new scene with an area 2D as the parent. The name of this scene should be house. Next up, I want you guys to add a tile map as a child and then use the interior.png graphic to create images for the house. To make all of that, you will need 3 layers. You will need the floor, then the outer walls, and then the interior walls. The order of this also matters. The floor should be at the bottom. Next up, you have the outer walls and then the inner walls. I suppose I should explain the tile span things a bit. We have lots of tiles. The ones for the floor are these. The outer walls, back in Godot, I want to make all of I want to rename right away to house. With that, I can save all of that in scenes, and I guess we could create a new folder. Let's call this one houses. In case you want to create more, you could create multiple in here, although I'm going to stick with one. Now with that, we have a new scene. This one is supposed to get a child, which would be a tile map. Now, I want to look at we can with this one separation between the various tiles, which I think is looking pretty good. Now that we have that, I can click on outer walls, and the outer walls are supposed to be this area. On top of that, we have these ending bits that we can use to close a door. Once I use it, this is going to make much more sense. So the between the floor and the wall. And to fill that, I have these ending parts. So I can made quite a few mistakes. My mouse over all of them, and then paint in, keep on working bits besides the ones for the entrance. The entrance is a bit special because those get these tiles. So not this one, but this one. That way we cover the area up to the wall, which I think looks better. And then we have another area. Although shape 2D, let's say we have a house, so now back inside of the left just fine. And this rectangle shape I have to extend because it's quite a large area we have to work with 2D. I am doing that. We still have the warning that we don't have a shape for this area 2D. That we can change quite easily. I want to give it a collision shape 2D, and the shape is going to be a new rectangle shape. And this rectangle shape I have to extend because it's quite a large area we have to work with. Let's say something like this would work just fine. You don't have to be too precise here. It doesn't matter that much, but this is looking all right. With that, we have a house. So now back inside of the level, still inside of the ground, I want to add this scene, and I call this one house. And now we can move this house around. We could give it a rotation and the transform. Let's rotate it to something like this. And then if I run the game again, I can move to the house, and eventually there we have it. The entrance is probably a bit too large, but it doesn't matter that much. And well, this is looking really good. We have a house. Although right now we don't have an interior. For that, back in the house, I want to keep on working. We could give it off the ground. I want to add this scene. And I called this one house. And now we can move this house around.
How he is moving and I'm not. Why? Why it always goes to soil?
We could give it a rotation and the transform. Let's rotate it to something like this. And then it doesn't matter that much with the tile map, easier to waltz. If you have in here or something, and then we can see we have actual interior walls for this house. If we should display more objects inside of it, this would also look much better. Something we are going to work on in a bit. But for now, this section got quite long, so let's finish it here. Now that we have a tile.
Those are not doors, I guess. So I'm done with this house. And I call it a day here. We are returning back to this Wednesday. Morning or night, I don't decide yet, but we will see. See you later. Good night.